Ladies and gentlemen, welcome to this session on cloud network and IoT. Do you hear me? Yes? Okay. My name is Guy de Velcourt and I will be your moderator during this session. This session will last approximately 2 hours and we will have different speakers on these various issues. And the first speaker we are going to hear, and I will introduce him in a few minutes, will talk to us about network architectures and from the internet, but also more broadly than the internet. And I think it's a very interesting approach because instead of doing things on protocols, we can also manage very sound foundations of interoperability and security with digital architecture. So let me introduce to Mr. Grassa. Mr. Edouard Grassa, welcome. So, Mr. Edouard Grassa, I would just like to introduce you briefly, and you can complement that you are from the I2CAT, which is a European funded organism in Spain, and you are particularly working on something on this kind of architecture called RENA, and you're going to explain to us what it is. Thank you very much. Welcome.
Thanks a lot for the introduction, Guy. So I'm Edouard Grassa. I'm from a research center called Fundació I2CAT in Barcelona. And one of the things we do is we are involved in the development of the RENA technology, the recursive internet architecture. So first of all, has anyone heard about RENA before? Like, hands up. I doubt it, but oh, okay, good. A couple of people. That's pretty good. So the point is to talk about what an approach that RENA can do for security in networks and applications. But first, I'm going to take just a little bit of time quickly introducing the main principles of RENA so that you can understand the motivation and why is this relevant to this conference. So what is RENA? As Guy has very well said, it's all about network protocol architecture, but network architecture are just words and it's being used in different contexts and means different things. So what we mean by protocol architecture is architecture in the sense of providing a set of patterns and methodology that guides network protocol designers to do their job. So when you have to design a new protocol for a specific environment or anything, you don't start from scratch. You leverage a set of rules of thumb and patterns that will guide you to achieve your job. Same thing as architects do with real buildings, right? They don't have to do work from scratch, but they have a body of science that they can leverage. And what's important to understand is that network architecture captures the rules and patterns that are invariant with respect to what type of network are we building and the requirements of individual networks. So in the case of computer networks, we would like to have rules and patterns that are invariant with respect to building cellular networks or wireless networks or data center networks or ISP networks. We would have to have a set of rules encoded into an architecture that would allow us to build any type of network. And this is exactly what RENA is trying to do. So how would an ideal network protocol architecture look like? What we have today, and this is the motivation for the RENA work, is not very neat, let's say. It's not something that has evolved, let's say, from a systems design, it's something that has evolved from multiple angles. So really the current internet architecture as we have it today doesn't provide a lot of patterns. It is fragmented. Some building blocks are quite broken. And in short, it doesn't help protocol designers to constrain the amount of protocols being designed. If we look at different types of networks, what we see is different specialized protocols for different types of networks, which are being independently designed and are repeating a lot of stuff. So when you put, if you look only at an individual network, it might not be that bad, but when you have networks that have multiple segments like data center, service provider, access, and you put all of this together, it's really complex. So what we would like ideally is an architecture that provides a lot more building blocks, a lot more patterns that constrained the, let's say, creativity of protocol designers, that didn't allow them to develop that many different solutions just for the sake of being different, but just the variability that they need to apply the architecture effectively for the problem they are trying to solve, being creating a very efficient data center network or a highly scalable IoT network and so on. So what we have today is, one of the problems we have is that there is not, let's say, a really well-defined internet architecture. What we have, we could say, is a set of protocols, a TCP/IP protocol suite, to call it in some informal way, that mostly leverages the layering that was proposed by the OSI architecture and has, in theory, this diagram that we see here. So it does have a physical layer, we have a link layer that deals with adjacent communications between different systems directly connected by a link, big wire to wireless. We have an internet or network layer, depending who you ask, that deals with routing and forwarding traffic over multiple link layers. And on top, we have the transport layer, which provides end-to-end transport services, retransmission control, flow control. And then on top, we have the applications. But in practice, this model is not good enough. So it is being constantly patched with new protocols that don't really match the layers. Like we have VLANs to be abstracted in different link layers. We have MPLS below the internet layer to be able to have, let's say, optimized routing and forwarding over individual networks. We have virtual networks, we have VPNs, we have tunnels everywhere, even at the application layer on top of HTTP and so on. So what we can clearly see here is that we have a theoretical model, more or less, but it is not useful enough to model reality. So what people have to do is extend it, and people extend it in different ways. Obviously, people in the data center space, they will extend it in the way that suits them. People in the service provider space will extend it in the way that suits them. And since there's no common background, there's no leverage. And that produces a protocol explosion. So in contrast, and this introduction could take a lot of time, but just going to the basics of it, we have the proposal of the RIN architecture. What we had before was this different number of layers, limited. So we have 5 layers here, each layer doing a different things. What RIN is based on is a different approach. We have a single type of layer, which we call the DIF, the distributed IPC facility, that repeats as many times as you need. So it's not that you have 5, 7, or 10 layers, doesn't matter. This is not a decision of the architecture, but a decision of the network designer. If in my network I need 5 layers, I will use 5 layers. If in my network I need 8 layers for whatever reason, I will use 8 layers. This is not a decision of a standards body, it's a decision of the network architect. And the layers are all the same. Okay, all they do is provide inter-process communication services, that is, allow 2 or more applications on top to communicate by name. That is, how would applications use this layer? So application at the left, application A, would register to a layer with a name that is independent from the network addresses that are managed by the layer. And then other applications would allocate flows to it. So application B would say, I want to talk to A. So the diff would allocate a flow to A, and the diff would be in charge of locating A, mapping it to an address, and allocating the communication resources for the flow. But then the diffs below this orange diff here that is talking to applications are the same. So for any given diff, diffs on top are also applications. So this is the recursive pattern here. Layers talk to each other the same way applications talk to layers. So it's all a repeating building block with the same API, the same interface, and so on. So it's a much more simple architecture, but yet equally as powerful as what we have today, because if we look inside the layer, what we have is, I don't pretend that you understand going through the detail of all of this, but the functions of each layer are organized into data transfer control, and layer management, and they can be abstracted into just 2 protocol frameworks, one for data transfer and one for layer management or the control plane. So these two protocol frameworks can be customized to the scope of each layer, to the requirements of each layer via policies, a sort of plugin. So the protocol frameworks tell you how you do, tell you that you have to do flow control, but it doesn't. What you can do is changing the flow control policy at each layer. You can do a sliding window, or you can do pacing, or the functions tell you where encryption goes, but they don't tell you this is the encryption algorithm for all the layers. You can change that layer by layer. So you can customize the different aspects of the layer, but you don't need to create a protocol from scratch to do that. All you need to do is specify and then code in software or hardware, doesn't matter, the behavior of this policy. So it could be an encryption policy, it could be a routing policy, it could be scheduling policy, and so on. So what we have here is you don't create new protocols, but just the policies to customize the layer. So we bind much more the work that network designers have to do, and you constrain the variability of protocols because you don't need to create them again from scratch. You just create the policies that plug into this common infrastructure. So we move a lot of the problems that are today resolved individually in every protocol and put that into a common tool set, which is the architecture. Hence, protocol designers have to do less work, which means there will be less protocols and have simpler networks that still can carry out the same tasks as we have today. So to summarize quickly what RINA is, it's a network architecture resulting from a fundamental theory of computer networking, and sees all networking as just distributed inter-process communication. Another thing that this does is unifying networking and distributed computing. The network is itself just a distributed application specialized to do IPC, but it's a distributed application, it's nothing else. Then there is a single type of layer with programmable functions that repeat as many times as needed by the network designer. It can be tailored to the problem that you want to solve, right? And all layers provide the same services. Instance of communications, which we call flows, to two or more application instances with certain characteristics. You can, when you request a flow, you can say, okay, I want these bounds on the delay, I want this maximum packet loss, I would like the packets I write to arrive in order or not, and so on. So you can specify which are the SLA for the flow, and then the diff will tell you if it can provide it or not, or then it's again a policy of the diff what to do if it cannot match the request that you are doing. So that is RINA, very 1,000-foot view. So what is relevant now to the conference is what properties of this design are contributing to security. So first thing is, since you have the same building blocks all over the place, you have a consistent security model from the application down to the physical wire. So you understand, it's very easy to understand what are the trust relationships between the different layers and also between the actors of a layer. So, for example, we have here at the top a blue circle representing an instance of an application process that wants to write data into a flow provided by the diff. So if it doesn't trust the diff below, what it will do is encrypt its data, right? It will can also provide message authentication code. So confidentiality and integrity is here in this vertical relationship. The diff itself is an application as well. So if it doesn't trust the diff below, we can also do the same. We can apply protection mechanisms to protect its information or also the information of the user. So it could encrypt the protocol headers or the payload of the application if it wishes to do so. When one of the members of these layers that we call IPC process wants to join a diff, here is where you have authentication and access control. And also, when an IPC process, so one of the members of this single type of layers requests a remote operation, for example, a control operation, over another one, this generic layer management framework, you also will have authentication and access control. If you look at a layer down, you will have the same. So just by understanding how two layers work, you understand how all the layers work. And here what you do is you're not protecting, the approach today is you have a protocol, you define a protocol. If you want to add security, you add security to this protocol. You have 10 protocols, you have to add 10 security frameworks. Here you don't protect the protocols, but you protect the layer. So all the information that the layer generates and exchange with peers in the layer is the one that is protected, irrespective of if it is routing information or if it is flow control information or anything. So the amount of security mechanisms that you need to protect the protocols in the layer is much less than you have today. And so here is just a schema of what are the different functions in the layer and what are the different parts that are relevant to security. What is important here to understand is, since we have the same protocol frameworks in all the layers, and what we do to provide security is write policies for the functions of each layer, like authentication plugins or access control plugins or encryption algorithms and so on, the plugins that you write are not depending on where in the layer you put it, or in what layer you put it, in a layer close to an application or in a layer in the physical wire. They just depend on the environment conditions, on the operational conditions of the layer. This means that if you do an authentication plugin for one layer, you can use it right away in any other layer. So it becomes modularly and reusable everywhere in the layer stack if that plugin is good enough for your security requirements. This way, one study we did is we did here an analysis of a very simple network that had 2 end hosts and 2 routers in the middle, and all the communication between both end hosts and the routers was protected at every link. So we were using the protocols for security at layer 2, layer 3, and layer 4, and then compared the same scenario with RINA. And we saw what are the security mechanisms and also the non-security mechanisms that are part of the security protocols, because some security protocols like the DTLS perform flow control or the limiting or the transmission control to be able to operate. And the number of these mechanisms was like 8 to 9 times the number of mechanisms required in the same network for RINA. So it is that much overhead that you could reduce by using this approach instead of using tailor-made protocols with their own security frameworks. Another important thing is that these have a scope that you control by design. So today the paradigm is the internet provides global connectivity, and then if you don't want global connectivity, you have to start putting different mechanisms to limit this connectivity. Like, for example, in IoT, I have my IoT device that will be connected to the internet, but I really don't want my home automation system to be accessible by everyone in the world. I want it to be accessible by me or by the people I define from everywhere in the world, but by no one else. So what I need to do today is I have to start adding firewalls, ACLs, VPNs, and so on to limit this assumption that everyone is connected to everyone or everything is connected to everything. In RINA, the approach is the opposite. So you have control connectivity by design. You want to have an open thing and everybody to connect, that's fine, you can do it. But if not, you don't need to deploy anything else. You can size the diffs and deploy the access control policies so that you can limit who is in, what applications can talk to other applications without adding anything else that was not foreseen already in the architecture. Also, there is no need for firewalls or external systems that do security because all of this is built into the architecture. And as I said, it's cheaper than what we have today, just due to the way it's organized. And a final one is separating, so having application names and not exposing that to applications, not exposing addresses to application is a huge win. So if we look first to the right part of the picture, we see the red circles are just applications which have an IP address and map to an IP address and a port, so IP address and transport port, in the TCP IP wall. And the big circle is the TCP protocol machine represents. So what we have today is, if you want to talk to an application, you have to know the DNS name, which gets mapped to an IP address, and a well-known port, because we don't have application names. The network knows nothing about application names. So that means that IP addresses, the addresses of the network, are an information that is well known by the applications. It is trivial to write applications that scan all the address space and scan for open ports and contact randomly applications. And like this, you have been built many botnets. Like, for example, you had the Mirai botnet that was a very trivial piece of software to write that was just scanning the whole address space, looking for open SSH ports and trying default passwords for the devices. In contrast, in RINA, you have application names. So there's application namespace that is completely independent of network addresses. Applications choose the application namespace, and the application name to address resolution is done in the diff, not outside of it. So no one outside the diff can address anything inside the diff. Scanning an application namespace, as you can imagine, is much more difficult, just because the application namespace is much bigger. So not divulging this internal information to the diff is to the application is a huge security win. Also, not having well-known ports is another one. There are no well-known ports to scan. And another one, this is more internal to the protocol, but since you have well-known ports, part of the transport protocol headers are already fixed. So if you want to disrupt an already up and running transport connection, the data you have to guess is much less than if all of these were generated dynamically, which is what happens in RINA. In the RINA, the transport protocol generates this connection and point IDs dynamically, both of them. So mounting the same attacks against TCP that with RINA is exponentially more complicated. You need exponentially more times computing power to do the same thing. So just to finalize the talk, a few hints of where RINA can first be applied. So right now so first on deployment. As I said, RINA can cover everything from the application to the physical wire, but that doesn't mean you have to change the full internet to start benefiting from it. You can deploy it in many places. You can deploy it as an overlay on top of IP networks, for example, doing the same thing or similar things that many application middleware does today, like peer-to-peer middleware applications or enterprise message buses or so on. You can deploy it below IP as well as a sort of next-generation transport solution for IP or Ethernet or so on. And next to it, via gateways as well. So some interesting use cases we are starting to work with people in the industry is peer-to-peer overlays, in which we have large-scale, really large-scale distributed applications, like, for example, distributed ledgers. This is one of them, that need to create a network of peers and need to do routing in a way that minimizes latency, but also that have a topology with specific needs. It could be random and so on. So this applying RINA here is a very interesting way to have a first deployment, also because it's all in software, it's all in the application itself, and it doesn't require major infrastructure change. And there are a number of benefits. Another area we are looking also is as a network overlay virtualization solution, for example, to provide data center multi-tenant virtualization, or in software-defined wide area network deployments, or for cloud networking as well. So an alternative to other application middleware, for example, to building microservices. Right now there are a number of middleware called service meshes that do a subset of the things RINA does and are not that much integrated with the underlying network as RINA is. So applying RINA there is another one. And also another potential use could be as an IoT solution, IoT networking solution, to replace, again, simplify a lot the IoT landscape. Everything that the current myriad of IoT protocols do, you can very easily do it with RINA just by changing a bit the policies of EFTP, again, resulting in a much simpler deployment. So what is the current state of the art? Right now, you cannot go to a vendor and say, okay, I want to buy RINA. We are not there yet. So we have a draft reference model and specifications available. We have open source prototype implementations that have been used in research projects, but are also being evaluated by industry. in different proof of concepts, and we expect to see really the first RINA products hit the market in 1 or 2 years, more or less. Probably in this overlay software area, because just the barriers of entry are lower than in the hardware market. And if you want to know more and or engage with the RINA community, we have a sort of one-stop shop for it, which is called PuzzionSociety.org, and you will be able to find there presentations, papers, videos, and mailing lists to join and participate on discussions. So thanks a lot for your attention. I will be happy to take questions.
Thank you, Edward. Big applause for Edward Grassa. Thank you very much, Edward. I think it's very interesting and very original solution that you have here. I mean, this whole architecture proposal that you have, I think I'm quite seduced by this. Do we have questions in the room for Edward? Any questions? While you think about your questions, perhaps yes, you referred to Mr. Pouzin, who was one of the web at the origin of the design of the web. No, so Louis Pouzin, what is his role in this project? Is it a kind of a how would you call that? Perhaps a parrain, kind of a. Is it a leader or is it only a mentor? Or
Yeah, that's a very good question. So so I2CAT, our research center, is just one of the partners working on this environment. The original ideas, let's say, from RINA came from a person named John Day from the US, and he had been working with Louis Pouzin in the past as well. So Louis is very supportive of this idea, which somehow continues the work they started, the pioneering work they started in the 70s and early 80s as internet pioneers. And as he himself says, he's an activist, an evangelist that is trying to make the concepts, make more people aware about the concepts and make more people understand why this could be important for them and could solve problems for them. So he's really helping us spread the word, let's say.
Okay, thank you. And another question I have is what would be the cost and the time difficulty for a company or a state who would like to adopt RINA? I've seen on the press recently that the state of Armenia was very interested to develop its local digital services or internet based on RINA. What is the difficulty and time schedule that they need to expect, or even for perhaps a large company or something who would like to adopt RINA?
Okay. So first, it depends on what sort of product or area you are targeting. You could develop really a small solution that does very specific thing, where RINA, is powered by RINA, but RINA is just hidden. You don't really see it, and that could be months and maybe a budget that is just part of any normal software development project. Like, for example, in many distributed ledger technologies, they have their own network layers and there are no overlay layers, and they do stuff. So you could do RINA for that. In just with the same effort, they would do the normal products. But if you want to do it like the scale, so this is something that is still ongoing. So under negotiations, but what the Armenian government is interested in doing is creating an excellence center on RINA. So they really want to train a number of scientists and innovators in RINA, have a parallel, let's say, knowledge base there that then can go to the industry and build products to sustain first internal services, but then export this to the world and use it as a competitive edge for the Armenian industry. So that, of course, takes more time because it's a longer-term vision. So it really depends what you want to do. You can start using it today in a very targeted environments because after all these years of research, the specifications, the knowledge is there already to start applying it on the real world. And you could go one thing bigger and do something more like long-term thinking, which pulling more resources and looking to expand in more areas. But you can start small or you can start big. You could do both things. Right now we are there, I think, we can start to really go and deploy it and build it for commercial use cases.
Thank you, Edward. Do we have some questions for this interesting distributed computed architecture? No questions, okay. Well, anyway, you can talk later to Edward if you would like so. Thank you very much. Final applause for Edward Grasso. Thank you very much. Thank you. Mr. Matthew Demore from Link by Net. Hi, Matthew. How are you?
Hi, good and
good?
you?
Thank you. Very good. So, Matthew, you're going to talk to us about secure computing and especially how to build digital trust with cloud environment. Is that correct?
Exactly.
Yes. Thank you very much. The stage is yours. The floor is yours.
Yes, we'll talk about the cloud transformation, which is part of the global digital transformation today. And the methodology I will talk with you today is just coming from all the different project we done with a lot of customers facing this kind of transformation, like groups like Saint-Gobain, Sodexo, LVMH, or DFS, which are international groups. And I'm the solution evangelist for the company. And we'll try during these 20 minutes to be focused on how really managing this cloud transformation from A to Z. We'll come with a few numbers just to be sure that you will not feel alone on this market asking a lot of questions on how to do it. Then we'll go through really the project management part just after talking about the scope of the digital transformation, because most of the time we'll see we forget some of the cornerstone of the digital transformation. And we'll talk also about two things: the security gap, don't forget it, security is still a very important thing, and then don't forget also to modernize the operations while transforming your global IT systems. So let's talk about some market figures. Why we say it's an hesitant growth? It's just because we'll see two different kind of trends, in fact. The first one is the market trends that this kind of consulting groups are doing, that are all saying the same. Cloud transformation is still, it's not a question now. It's really the big move, the big shift that is currently in progress. Gartner is saying, for example, that by 2025, 80% of companies will have opted to shutter the traditional, so physical data center to go there, to go where? To go into the cloud. IDC is saying that in the next 2 years, 60% of IT spending will be cloud-based. Don't know if it's the case in your company, but that's really how now more and more people are consuming IT. And the last one, KPMG, that is saying that the global cloud market, and that includes all type of consumption, could be IaaS, PaaS, or SaaS, will increase by 2.6 till 2026. So the big shift is here, but on the other hand, we still have a lack of IT department that are really taking the reins of the transformation. Deloitte, in this year's study, is saying that 10% of the CIOs are really digital vanguards in their organizations. They are mostly just following the trends, in fact, but not really driving it. Logic monitors Cloud Vision, which was also a study, and 60% of the people who respond say that security is still the biggest challenge for operating into the clouds. And that's why we'll talk about security and the fact that it's really something that we should not forget during this big transformation. And then the Arvenash and KPMG report saying that 25% of IT executives are reporting a lack of talent to hold their organization back. And we'll also see that people are key during this transformation. So now we have the fact, in fact. We can now talk about the scope of the transformation. What are you thinking about what could be the first scope? Technology? Yeah, that's the easiest one, in fact. When we are talking about cloud, immediately, okay, I want to go serverless, so to be able to have platforms without server, things that can scale out and scale down automatically. I want also to use some artificial intelligence technologies to be able really to have more insight on my data and trying to have some business oriented decision that could make me save monies. I want to also use machine learning, big data, all these buzzwords that we currently hear. And in fact, technology is not the biggest challenge. It's really the easiest one. If cloud transformation or digital transformation was a technology challenge, it's just a very simple one. Second scope, the infrastructure. And in fact, we see that a lot of physical data center will be completely cut off. And that's a big question for IT department to know, okay, where to go? Do I need to keep part of my physical data center because I just have very high confidential data or very specific applications that cannot run into other system like cloud? If I want to go into the cloud because maybe my top management told me you have to be cloud first or cloud ready, then which cloud do I need to use? Because there's a lot on the planet currently. And if I say, okay, I will use some clouds, and I know which one, okay, but what type of usage? Do I want to go with private clouds, with public clouds? Do I want to have a mix? And that's a decision also to take. So it's part of the challenge. Third one, the security. It was the one part of the previous talk. Security is still a big challenge because there's two major types of security. What we will call the security of the cloud. Okay, if I want to use Google, Amazon, or Azure, are these clouds secure enough for my company, for my business, for my information security policy? So the security of the cloud itself is very important, and we have to assess it. But also there's the security in the cloud, because these cloud providers also are giving all the company a lot of security services that can be used. But first of all, they have to be known by the end customer. You have to know how to use it, how to tune them, and to apply them to your own information system. And as each cloud has its own security services, could be a mess sometimes. And then the security operation center. Do I need to keep my security operation center? And if yes, how can I use it on applications that will be deployed into the cloud with different tooling, with different process, and a different way of managing the security. The fourth one, the mindset. And it's maybe the most important one for cloud transformation, because shifting technologies is a thing, but shifting mind of the people that are working into the company, it's a completely different thing. If people are not trying to or are not feeling part of the cloud transformation, you can have sometimes a two-speed company. The ones that are part of the transformation and feel comfortable and they adopt new technology, new way of working, breaking silos, working with other people, sharing responsibilities. And on the other end, you will still have people that are just in their own way of doing things because they were doing it for the last 30 years and that just don't know how to project themselves into this new organization, new way of doing things. And these guys, we need also to accompany them. We need to train them. We need to make them part of this global transformation, still part of the company. So changing mindset is really a key thing. And the last thing will be the operations. Don't forget also to modernize your operations. It's very important. If you are still operate your IT system with an old-fashioned ways, but you are fully serverless, we'll have some problems. Use automation. Don't be shy about also using managed service provider to help you manage services, and pre-build your service catalog. It's very important because with a service catalog, with automation, you will be able really to gain a lot on your time to market and really be able to deploy new services quickly with a high value added. So these are what we think are the most 5 cornerstone of the cloud transformation. Maybe you have others in mind, but these ones are very important to address. Then let's talk a little bit about the methodology that we are using. Find your path and measure. We'll see that measurement is key when you want to transform. It's also part of the DevOps mindset. If you have to do something, you have to also to think how to measure the impact of what you will be doing. Otherwise, just do nothing. Because if you cannot measure, the action maybe will not have the results you wanted. So first step is to be able really to fix the business objective. And we are talking about the business objectives. In fact, if we are starting the digital transformation without having a top-down approach, the support of the executives and the business objective of the world, the global company, will face just a part of the transformation that will be only applied by the IT department, still have some shadow IT for the marketing, the communication side, and you will not align your whole organization. So that's why what we are doing most of the time is meeting the executive, meet the business, meet the IT, and be sure that all objectives are fully aligned and that the global executive, all the executives are sharing the same goals, and we have to write the goals down. KPI that we can measure at the end of the project. The second thing is getting ready. How to get ready? Just start with a proof of concept. Be sure that the global transformation you will manage can be effectively done. And this can be done just by some proof of concept, and use the same transformation team that have been managing the proof of concept. Capitalize on it. This will be your best representative inside the company to help the others just to feel part of the transformation. Scope also the transformation. You will not be able just to make a big shift. just in 1 year of the whole company. It's completely impossible. So we need to go step by step. And for each transformation step, all the impact has to be also measured. Maybe you will touch an application that is linked to another organization or part of your global ecosystem, and if the approach is not a systemic approach, sometimes we see that there is a lot of non-managed impact that can be very difficult to handle afterwards. The operational model also has to be written in advance to know, okay, once we will be into the cloud, how I will operate my information system, and then also set up the hosting target. Which cloud? What type of cloud? What type of architecture? Then plan. Plan all the things. So build the foundations. If you said, okay, we'll go fully in the cloud and it will be with Azure, build your Azure infrastructure to be able to support your transformation. Mind the security gap, we'll come later on it. Script as much as you can. Pre-develop your service catalog to be able to automate it afterwards. Communicate a lot. You have to do and tell everyone what you are doing. Otherwise, all the people will still think, okay, but what they are doing, what is the project, is there any ROI, KPI? If you are not communicating, you will be just a small project within the global organization, and phase things. A proof of concept was made, and then go just piece by small piece. Then you can do the move, find your own transformation mode, lift and shift, rehosting, integrate things, test it, and once everything is tested, then go in production. And then you can maintain. So KPI, ROI can be now measured. Be sure you can manage the availability and the performance. Don't hesitate to use a managed service provider and a cloud management portal that will help you also to deploy the clouds into your organization. We are talking about security. How much time do I have, Guy?
2 minutes.
Okay, thank you. Don't forget about security. The best thing will be just to do, at the early beginning, a risk assessment. Okay, just to be able to know where are the risks, what are the very important assets you want to protect, and then do your transformation with cybersecurity by design on your architecture, your process, your tooling, and your management. Then don't forget the operations, and 2 ways of modernizing your operations. Use a managed service provider that will give you 24/7 services. Already people that have that are experienced on it, and certified with SLAs, and being able to also manage a different cloud. And your cloud management platform will be able also to give the business the capabilities to deploy themselves into the cloud with the integration of your own security and performance requirements. So this global project is coming, like I said, from our experience on it. So Link by Net is accompanying the client transformation via consulting, cybersecurity software, and managed services. And I will be happy to answer your question if you have some.
Thank you very much, Mathieu. Large applause.
Sorry for the time.
Mathieu Demore. No, very well. What a journey. Huh?
Yes.
It's impressive. All you have to do to become a cloud enterprise. But effectively, I'm very impressed because one of the person who should be with us today and unfortunately couldn't come at the last minute was one of the Nokia top manager, and his essential message was that today all the networks intelligence is on the cloud. And today developing telecommunication networks is first developing intelligence in the cloud and all the project that comes along.
Yeah.
So so I think it's a very impressive journey for all the companies and all for the administrations who need to do that. Do we have some questions here in the room for Mathieu Demore? Is there any questions? Yes, please, sir.
Can you detail what you're talking about service catalog?
Okay. A service catalog is a catalog where you will put all the change and operation that you will be able to do from a recurring point of view later on, like deploying a server, updating an operating system, deploying a new function in Azure, for example. So every single action that can be pre-built, pre-draw, and you can activate it with a one-click process, for example.
Okay, thank you very much. Any other question? Okay, thank you. Then thank you very much, Mathieu.
Thank you.
And we will continue our session. And well, you can ask Mathieu about more. You can contact him after our conference. I would like to call now Mr. Mathieu Pujol from Pierre Audouin Cybersecurity. Welcome. A big applause for Mathieu Pujol.
Hello.
So Mathieu, you will. We are very interested also how to bring security in the cloud, and this is one of your core expertise. So perhaps you can let you the stage to explain to us how we can do that, how we can achieve that.
Yeah, no problem. So I will explain a little bit about my company. So we are an advisory company. We are 200 mainly across Europe. And our business line is very simple. We help people to select their technology, select their provider, and we help the provider to be selected by those user companies. So it's quite a crystal clear business model. So now I will share with you what we are doing. First, that's a concept we are working with the user company. So that's what we call the new CIO office, what he has to do, how he has to do it. So it's quite clear. You have to automate and so on. You have to be secure. You have to have open system. You have to have also, as it was said, I have not mentioned it, but you will see that with the first Mathieu, the second Mathieu, we complement quite well on. We have some issue that I will mention at some moment, but normally we love cloud and security, as you can see there. You see also the automation is very, very important. And also what is important, we'll get back to that, full stack management. When I'm speaking full stack management, don't take it like too techy. It's meaning management from the business to the hardware, not forgetting network, storage, and so on. So that's how I mean there. What is important also is that many of the buzzwords that we are using today are based on those cloud architecture. You know, if you speak about IoT is just cloud architecture. You know, it's not more than that. Specific cloud architecture, but that's cloud architecture. Smart cities is cloud architecture. Big data is cloud architecture. Artificial intelligence is cloud architecture. We do AI. I'm started in AI. In fact, before we cannot do AI because we don't have storage, analytic, and computing power. Now we can do it because we get this from the cloud. So the cloud is quite essential in the way we will do IT and network in the future. So that's a survey we have run in Europe. What is interesting there is that you can see that around 15% of the company are the front runners. So you know we are not very far from what the other Mathieu already present. What is very interesting is that there is just 4% of the company who are in the middle of nowhere concerning digital transformation. Of course, it's not all the company there. It's company above 1,000 people across Europe. So, you know, that's not your bakery at a street corner. What is interesting also is why they are doing this. As you see, why they are doing this is really to confront their environment, is really to have new clients, is really to propose new stuff to the client. So that's very interesting because that's very business focused. It's not changing your architecture for the sake of changing it, for optimizing it, for cost. Is for business issues. And that's something that we get back there too. So in red, that's cost. So why are you doing this? So cost is number 4, which is very rare for people like me who have been working in the IT for a long time. All the time people ask you, oh, lower your cost, you're spending too much, and so on. It's not possible, you are... we are throwing money by the window because of you and so on. But here we see that with the digital transformation, what is interesting is that we get very business-centric issues that are put first, like performance, like innovation. And something that is interesting and that bridge the gap between cloud and security is a compliance issue. Compliance is starting to be very, very big. You know, we speak a lot of the GDPR not long time ago. You have to know that now there is something in the US called the Cloud Act that have huge impact if you are competing with American company. You have also the NIS directive from the European Union if you are a vital infrastructure operator. So all of this, you have to do it. Here, that's some data from our company where we see that today the market in Europe is 20%. 20% is cloud. Okay, you know, some people may be exaggerating sometimes when you ask those questions, but yeah, 20% is what they declare, and they declare that they will more than double this by 2022. So, what is interesting in all of this for the people who have been for a long time in the IT, like me, that's just business as usual. When I started the IT, my IT professor was saying, oh, mainframe is dead and so on. Nobody will use mainframe in 10 years. Now it's 25 years after. There is still, in banks, in a lot of companies, there is still mainframes. So what is important to see here is that it's very heterogeneous. So you will have your legacy that are still running, and sometimes you really don't need to change it. There is your own cloud infrastructure on-premise managed by you. There is your private cloud, and there is a public cloud. All of this can also be segmented also by technology. Here I'm doing connected car. Here I'm doing utilities. That's IoT. That's edge computing. So this means that it's starting to get very complex. What are the main trends that we are looking there? That's where I get maybe a small difference with the other Mathieu, is that of what we are looking, we are thinking that there is a return to the private cloud. For one very big reason is that we put more and more of the added value of the value chain I presented before. We put it more and more in cloud architecture, and at one moment, it's really the core business of a company, this value chain, and it's difficult for them to give it to a third party. For example, if you look at a company like in France, Schneider Electric, they are doing 30-35 billion euro revenue. Out of this, there is already 1 billion is IT that they sold to third-party company. If you take a company like Bosch in Germany, it's the same. They are doing around 1 billion. And why they are doing this? Because, for example, they discover that their injection system for the car engines is all IT now. So they have to master the IT brick. So they develop in open source their own system. They propose to their client Microsoft, VMware, or their own open source based system, because it's core in their value chain. That's why we are thinking that the private cloud will get back. Then there is the DevOps. DevOps is very, very interesting because I don't know, it's the same. I have some experience now. We always speak about IT and business alignment. DevOps is just about this IT and business alignment. There was always people who are not going at the same speed. DevOps is about this, but DevOps is very difficult. I have interviewed the CTO of Allianz, a German insurance company, and I was really surprised that he's a CTO that is owning the DevOps. Well, very often, as he comes from the agile methodology, to have with the dev stuff. And then the guy told me that what is difficult in DevOps is the ops part, not the dev part, is when you put it in production. So for me, DevOps is there to stay very long time. A lot of companies are going in this way, but not everybody is able to do it. This Allianz guy told me that he thinks that only a quarter of his IT workforce is able to do DevOps. They are able to change to become DevOps. So there is also there a resource problem. Other trends, of course, the microservices. Let's say what is very interesting with microservices is that we get a first wave of cloud computing. In fact, this wave, I have the tendency to call it the cloud mainframe. So we re-centralize everything. And again, you know, the history against Istoclit, a Greek guy was saying, a Greek philosopher was saying that history is just something that is eternal beginning, is restart again. It's the same in the IT. With the microservice, now we discover that we cannot manage everything centrally, so we have now technology to decentralize it. Also, it's very, very useful when you are making IoT, edge computing, for example, connected car and like this. And of course, it's at the core of the DevOps strategy. And something that will change very quickly now, it's the IT that is really colonizing the OT, the operational technology. That's already have happened. We speak before about network architecture. We know that now all the biggest carriers across the world are implementing network function virtualization and software-defined network. Why? Because they are using IT technology for their OT. Their OT is a network. This we are seeing now in the factories. And this has a very big issue. There is security. Because when you are putting IT inside the OT system, you are opening them, if you want to do, for example, Industry 4.0. But the problem, you are opening it, but the security has not followed. So that's also a big issue for the company that want to do this. There I'm also well aligned with Link Bayonet about this. Management is a key. Management is a key. What is very important first will be the visibility. We speak about shadow IT. That's quite terrible in management and security standpoint. That's really terrible. If you don't know the stuff, you cannot manage it and you cannot secure it. It's simple as that. So visibility is very important. An holistic approach, meaning that you know or you try to know nearly everything, because all the stuff are related. For example, if I take the example of Airbus is putting now a project called Albatros to protect its subcontracting company. Because they know that all those subcontracting companies, even big companies like Zodiac, they don't have the capacity of cybersecurity such as Airbus. So they want to help their subcontracting company to get better protected, because they know that those spare parts are a danger in cybersecurity. Maybe we have seen fridge that were attacking networks. Maybe we'll see plane seats that will be attacking the main plane system. So that's very important. So here you see also stuff like security, the first issue, but you have also interesting stuff like complexity. As it was said in the first presentation, complexity is really an issue, and how to tackle complexity, you have to have a unified management platform. That's a key point, you know, the single pane of glass, that's a key point for good management. So here I put some use case, so I will give you some percentage about this. For example, a bank like BBVA, which is one of the biggest banks in the world, they are already around 30-35% of their IT in the cloud. And they are moving very, very fast there. If you take a company like Entity, they are a front runner about network SDN and NFV. Nearly all their network now is functioning with those technology. And they are all copying it, AT&T, Dutch Telecom, Orange, and so on. If you go to BMW, PSA, when you take a car configurator over the internet to choose your car and the link with this with the retailer, all of this is have been done out of cloud technology. The UK government is in the top 5 of the most digitalized government. You know, I'm a fan of rugby. It's very hard for me to say good stuff about the British, but here on this they have been very good, and they totally changed, as it was said before, they totally changed their state of mind. They break all their big outsourcing contracts, and with a cloud framework, they have been able to contract very small company to have the security level they want. For example, Amazon cannot manage the British Parliament. That's forbidden. That's a British company called Interroute who is doing this. There is a company like LVMH. If you know the architecture of LVMH is a sort of, it's a myriad of middle-sized company. Cloud was a way to better manage it. Then you have Walmart. Walmart is very interesting because Walmart is a company who work with them about public cloud benchmark. So they benchmark their internal architecture with all the public cloud except Amazon for one reason, because they are the bitter enemy in the US, but they make it with Microsoft, Google, IBM, Rackspace. And very interestingly, at the end, Walmart in computing the internal architecture, all cost added. So there is a network, there is everything. As I say, full stack. Walmart was 20% less expensive than any other solution they could find in the market, even with their cost, with their rebates, because they are big companies, they can get rebate. So that was for computing, and that was more than 40% in storage. So that's why I was saying, you know, you could have a return also of the private cloud. Of course, not all the companies are the size of Walmart, which is one of the biggest companies in the world, and sure have enormous data centers. So when we speak about the catalyst, the first key catalyst I wanted to underline there is security, because you cannot do digital transformation, whatever you want, cloud and so on, if you don't have cybersecurity. Why we speak about cybersecurity so much those days is because the hackers, the criminals, they already have made their digital transformation. They are already using the capacity of the cloud, the capacity of the big data, the artificial intelligence to attack. So, you know, you have to follow. It's really normal. It's the old story about the sword and the armor. You have to follow. Something that is interesting also is another survey we have done there. Public cloud, and it was said before, public cloud is the first vulnerability today for the company we survey. But what is interesting is that people, nearly the same percentage, are saying that they are using cloud to get protected. And why they are doing this? Because cloud has an innovative solution. So it's a bit what we say about, I don't know if you know this image of the yin and the yang in the Asian philosophy, opposite but complementary. So that's a bit the problem between the cloud, that is a vulnerability generator, but this also a way to better protect yourself. So the second catalyst, in my sense, is the open source. We briefly speak about the open source. The open source is good for a lot of things, but where we're thinking it's important is permit you also to get back some of the added value you are creating, because as you are putting more and more process, more and more data, more and more activity in the digital, at the end you could be only a digital company, and that could be quite dangerous to not master your value chain there. So of course, there is company, if I take, for example, as I say, Bosch, they make the choice of going with OpenStack and Cloud Foundry, while Schneider Electric, which is also a competitor in a certain part of the IoT business, choose to go with Microsoft. So this depends. There is no defined choice, but the open source is really there to help you. As you have said with the RINA example, open source permit to develop very quickly technology. And also when you look at cloud computing, it's just open source technology. Internet is just about open source technology. Look at the biggest framework that we have. If you go to microservices, in fact, microservices nearly does not exist out of open source. Docker, Kubernetes, all of these are open source. So it's very important that company masters the open source. And as you see in this study, you can after send email, I can send you all the link to the studies. It's a study we have done. This is specific for France. So, okay, you know, the French, maybe they like a bit too much open source because, I don't know why, but because they are like this. But, yeah, it could be interesting for you to see that there is a lot of those companies who are saying that open source is strategic for their digital transformation. And that's something that evolved from 10 years ago when I started to get interested in open source. Before it was a tool. Now it's a strategic platform. And that's a very big difference. So here you have some link if you want to go to see what we are doing. There is most of what I have present is free of access. You have the white paper, the full surveys. So yeah, don't hesitate. Here it's how you can call me and so on, my mail and so on. So don't hesitate. Thank you.
Thank you, Mathieu. A large applause for you. Thank you very much, Mathieu. I'm impressed, I must say, with all the knowledge you shared with us, both in cloud technology, in cloud models, and also in your market knowledge of who is choosing which solution and for what reasons. So that's very impressive. Do we have some questions here in the room from Mr. Mathieu Pujol? You should not hesitate to ask questions. You know, it's your last chance, and tomorrow it will be too late. So do not hesitate to ask questions. Well, I have a questions for you, Mathieu. Would be for a new company who would like to begin a project on the cloud, and especially perhaps for not for a company which is perhaps 2 or 3 countries, but it's not a worldwide company, so the cloud is not obvious. Or what are usually the first steps of your conversations when they come to you to say, should we go on the cloud, and what kind of cloud, and how much the level of security we should put? Well, how do you? I mean, what are the first stage when they get to you, and how does it?
The first stuff, before all, when it's about cloud, we look at the security constraint that they get. If they have not, for example, there is in the healthcare, there is some company that we totally advise them to not go to any US-based cloud because even if their data is in Europe, as long as it is operated by American people, is under the Cloud Act. And Americans have a very nice intelligence system, especially in the healthcare. So it's important to look at those points. After, this depends on the capacity of the IT inside. Sometimes I think it could be better to go to guys like Orange, Dutch Telecom, or Link by Net that will give you managed service where they will take all the complexity out of you instead of you going directly to a hyperscaler. An hyperscaler is very nice when you start, but after to manage them is really not easy, and you start to realize that you are paying too much. So having managed service, I think, is better, and the prices are not that expensive.
Okay, thank you very much. Yes, thank you. Do you have some more questions from Mr. Mathieu Pujol? No. Well, thank you very much, Mathieu, and and the people can contact you later. So now I would like to welcome Mr. Dave Lewis from Duo Security. Mr. Dave Lewis, how are you? Very good. Very good. Do you have a mic here?
I have a mic over
Okay, and we're going to start your presentation, and I would just like to say the name, which is Zero Trust and the Flaming Sword of Justice. So this is kind of a mystery here, but I'll let you explain the mystery.
Well, I will indeed, and thank you for having me. And thank you for all of you sticking it out. Yes, my name is Dave Lewis, and I work for a company called Duo Security. And the whole idea about the talk is I don't give vendor-centric presentations, even though I work for a vendor. I give talks that are very much about sharing security lessons with folks, as opposed to saying, here, click, click, next, and we'll move on to the next thing. So, a little bit about myself. I have spent the better part of 25 years in the security space. I have done everything from being a firewall administrator to being a CISO for a power company. And I have lost a lot of sleep along the way. And I am Canadian, so I apologize for my thick accent. I will just say that right out of the gate. Canadians are really easy to spot, though. We usually are dressed up like homicidal maniacs and racing across a sheet of ice at a very high rate of speed. So I do work for Duo Security, and Duo Security is a company that helps to improve your zero trust setup and making sure that your environment is safe and secure. But recently, we were bought by Cisco. So we went from a 700-person shop to a 70,000-person shop overnight. And this is really cool in that it is exposing us to markets around the world. So we had Duo, we had Cisco, and then my boss rather cleverly said, oh, we'll call it Disco. Unfortunately, that didn't take off in the marketing, but I do enjoy it. Our mission is very much to protect your mission. So, Zero Trust. How many people here have heard of Zero Trust by a show of hands? Okay, good. That's more than I anticipated. Zero Trust is an idea that a lot of vendors like to say, oh, no, it's this way or it's the other way. But the reality is Zero Trust is something to aspire to in an organization. You want to move towards a security paradigm that works for everyone and making sure that's done in a really sane way. The problem here is that because there's multiple definitions out there, we get often lost in the weeds, and far too often we don't know which way is up. It's very much like when somebody says, what is love? If you ask 10 people in a room, what is love? You're going to get 10 different answers. This is the easiest way I have to describe why you need Zero Trust. The premise here is that everything is on fire. Everything in your network is being attacked on a regular basis, either inside the network or outside the network, in the cloud or on-premise. And when you have that as your starting point, Zero Trust becomes very simple to understand because it is about making sure you're securing all aspects of your environment. This is how security people feel all the time. The one valuable lesson I've learned over the years is castles don't scale. As a security paradigm, we have to continually evolve. Now that we've moved into the cloud, and to be very honest, when we're talking about cloud implementations, it doesn't really matter where it is from a geopolitical standpoint. You have to look at it as, is my data encrypted? And do you hold the keys? If so, you can drop it anywhere you want because it doesn't really matter. Your data is encrypted and you have the keys. It's really not susceptible to any sort of intrusion. But just because something's inside your firewall, don't trust it. That's the best way to look at things. Because just because it's on the inside, that's not necessarily going to mean you're secure. Over the years, I've heard far too many times, it's okay, we have a firewall. That has limited utility when the systems on the inside have not been patched in 6 years. Also, passwords. It's always great to be environmentally friendly, but reusing passwords does no one any good. If you are using the same password for your internet banking, as well as filing your taxes or shopping for whatever type of toys online, and one of those sites gets compromised, the attackers, and I very much like to use that term purposely because I'm a hacker, boo, we tend to want to take this word very much back because hacker, for us, is very much about someone who has a demonstrated curiosity. So, passwords, please don't be environmentally friendly and reuse those. Because a password has limited value. A static password, it doesn't matter who has it, as long as you have it, you have access. The idea here is you want to have something better than a static password. ultimately, let's see, is this going to go? Oh, there we go. When you try the password and it doesn't work, then people are going to tell you to go away. You want to have something that authenticates who you are in addition to gaining access to whatever authentication levels you need. A great lesson from history is the sack of Rome in 410 AD. Spoiler alert, before I ever got into cybersecurity, 30-odd years ago, I was taking a course in archaeology, and this is one of the things that came up. The Visigoths sacked Rome simply by using their own security paradigm against them. They set up shop around the city and cut off access to all supplies. Eventually, the Romans ran out of food and water, and they said enough. And they opened up the gates, and the city was sacked. They used their own security against them. So this is why we have to constantly iterate, constantly improve our security paradigm. Because in Canada, we have a thing called bears. I'm sure they're here too. I'm not actually really sure. But we have a lot of bears there. And the whole thing here, the joke was, as long as you're faster than the hiker behind you, you're fine. But these days, there are far too many bears from a cybersecurity perspective. This is usually how everyone sees information security or cybersecurity in their own corporate environments. All too often, this has been an earned idea. Cybersecurity people have historically done a very, very bad job of working with others and playing nice with others. And this is something that we need to dispel. I ran into somebody that I worked with years ago, and I actually referred to him as the flaming sword of justice because his response to everything was, we need to fire that person. Which does not really serve any good purpose. So, we have to improve that because data breaches are happening all the time. How many people here are familiar with Amazon S3 buckets by a show of hands? Cool. All right, so by default, when these buckets are set up, and for those of you who don't know, this is a data repository. You can put image files or Excel spreadsheets, whatever you want into them. If you set these up, by default, they are not publicly accessible. By default. A lot of these companies that are being compromised, when they say they were hacked, they weren't actually hacked. Unfortunately, they had left the door open because they had made those S3 buckets world readable. Data breaches are not something new. Back in 2012, I started tracking a lot of them, just because apparently I don't get out much. And I compiled a list from my site, liquidmatrix.org, where I tracked all of these. And back then, LinkedIn had 6.5 million records that was compromised. Back then, that was big news. Flash forward to today, we're looking at orders of magnitude of billions of records being compromised in each data breach. We can do better than this. And I know what I'm talking about because I lived through a data breach of my own. This is the actual compromised web page on one of our systems that unfortunately was supposed to be taken out of service, but when they said they would take it out of service, I made the mistake of not following up with them and not making sure that it was taken down. So I didn't blame the team that didn't take it down. I blame myself for not following up with them and articulating clearly the risk. Because as soon as this happened, CBC, which is a major Canadian publication, and all sorts of other publications, were very quick to phone me up at 9 o'clock in the morning. So, what's open in France? There we go. Right now, this is how many ports are on the internet in France specifically. This is not necessarily a bad thing, but of those 9 million, or 9.8 million, can you be sure that they're all secure? Unfortunately, not all of them. To put a finer point on it, in Paris, this is how many ports were listening at the time that I took this, and this obviously will vary from day to day. And even in Cannes, that's how many ports were listening yesterday. This is all freely available information on the internet. I didn't have to scan anything. There are repositories out there that store this sort of data. And to break it out, we have 158 webcams, 596 compromised databases, and just almost 4,000 industrial control systems that were online. These are targets of opportunity for the attacker. So here, just some screen caps from some of the webcams that were available last night. 1, 2, 3. Why would people have this available is beyond me, but just an example. And here's another thing. Here's the actual management interface for somebody's webcam at home, where you could actually go in and manage their thermostats and all these sort of things. No password required, none of that. I didn't even have to connect to this particular device. This was a screen cap that was stored in an online repository that actually goes through and checks all of these things. So, zero trust as a value proposition. Actually, the one thing I like to do is remove the idea of zero trust and talk more about it from a unified access to security paradigm. So we'll fix that. What you want to do is you want to look at devaluing stolen credentials, because every time credentials are stolen, there is a monetary value to these on the internet for the criminal element. The attackers love to get these because, by and large, humans being who we are, we tend to reuse passwords. So they can actually reuse these passwords on other sites and make money, be it gift cards, ordering products, compromising your bank account. These are things we have to look into. We need to remove low-hanging fruit, easily accessible systems that haven't been patched in a long time. We want to look at making sure that we complicate the lateral movement, because an attacker, what they do is they'll break into one system, but it doesn't stop there. The attacker will then try to move throughout your network, hopping from one system to another if they've gotten past your perimeter. And you want to make it that much harder for them. You want to look at doing bastion hosts. So years ago, I was working for a power company, and I think it was about actually 2003, I suggested making bastion hosts. And the idea here is that every laptop, every desktop, every server on your network is hardened down as much as they can be, still allowing them for them to be functional. I survived because the people that needed to maintain these systems, I was fairly certain they were going to run me out of the door without opening it. But this was an idea that has been around for some time. In 2004, the Jericho Forum came forward with the idea of deperimeterization. This really is one of the forerunners of zero trust. Because unfortunately, historically, what we would do is we'd harden all of our systems in the DMZ, and then moving towards the internal systems, we wouldn't take nearly the steps that we would for internet-facing systems to protect the internal systems. I always found that very curious. So, if you're looking at going forward and doing a zero trust type of idea, you have to be sure that you're setting your expectations. Because if you're going to look at approaching zero trust in any way, shape, or form, if you don't have some sort of battle plan in place, things will go horribly wrong. You want to aspire to a zero trust network. The idea here is don't look at it as a point in time. When we get to that point, we're done, because that's never going to happen. It's constantly an iterative process. It's a game of increments. Every little win is an improvement. When you start with the bare basics of doing an asset inventory in your network, and that's not actually that simple for a lot of enterprises. If you have anything over 1,000 nodes, you'll know how much of a difficulty that is. This is one of those things. Once you have that asset inventory, then you know what you have on your network, then you know what you need to protect. And determining those priorities once you have that in place. It's basically like doing a risk register for your environment. You want to know what it is you're trying to protect. So for a zero trust, let's make that, unified access security. So what you need to do in order to start getting where you need to go. Like I just talked about a moment ago, you want to look at getting an asset inventory. You want to look at a better way of doing user management. One company that I worked at years ago, we had a user environment where we went through and we audited all the accounts that were available. One particular account really caught my attention. This was someone who had left the company 10 years previous, has super user access to every system on the network, and I mean everything, and he passed away 2 years earlier. This was still active, and it had a trivial password. So this is one of those things. If you're not going back and looking at the accounts, having a proper staff add remove process in your environment, you are really setting yourself up for some difficulty. You want to look at device management through a uniform security policy. Why should the CIO have a different configuration on their laptop than somebody working in finance? Why is it not uniform? This is something that is attainable. This is something that we can do. We want to look at having a defined, repeatable process. Because if you're running around constantly doing firefighting or going, oh no, we need this system to connect to this network. Now, this is stuff that we can identify early on in whatever project it is we're working on and move forward in a clear and concise manner. So once we have that asset inventory, once we have the users that are all locked down in a way that they can still operate, and making sure you have defined repeatable processes and devices with a secure configuration across them, you want to look at the data that those are providing. Every system on your network is talking to you. Are you listening? So this data can show anomalous behavior on devices. It can show when systems are out of line. If systems are not updated for, say, 7 days or whatever your timeline is that you set, that'll lock it out until somebody does an update. and network zone segmentation. This is the one that really gets me because I've been doing this for about 25 years now. And when we first started working on project, or when I first started working on projects with my team 25 years ago, this is something that we did. I have done work for various militaries, various governments, all sorts of corporate environments, and this is one of the key pieces of the puzzle. To be fair, they're not all like this. One company I worked at had a flat network, and for those of you not aware, flat network means I could go anywhere on that network with no problem. Global. I could sit in my desk in Toronto, I could access systems in Kuala Lumpur as if I was on a local network. It doesn't need to be this way. We can do better. Now, authentications are another thing. When you're talking about all these things that you're locking down, what are the attackers going to do? The attackers are going to shift their focus. They're going to move to other targets of opportunity. Case in point, APIs. The attackers are now going to go after the APIs, and if the APIs are not properly secured, they're going to be able to gain entrance that way. A favorite story of mine was when I was on Twitter years ago, a friend of mine was able to query the Twitter API and add people arbitrarily to his user followers. And I thought this was really neat. So he added 2,500 followers in about 2 hours without ever getting their permission. And we couldn't figure out how he did it until he explained it later that he had accessed their API directly. These are the kind of things you have to consider. The attackers are always going to be looking for new and exciting ways to get at your data. And the supply chains are everywhere. We have to look at it. Anytime your computer is connected to anything on the network or all the different components on your system, every one of them is working together in concert. Each one of those presents its own potential risks. So we have to make sure that we're doing a due diligence on these pieces. This is one of my favorites. So years ago, I was working with one company, and I hired a team to come in and do a penetration test for us. Sorry. What they did was, their whole idea was to act as an attacker to see if they could breach the network. And I thought, okay, this is cool. We're going to bring them in. I'm sure it'll be fine. I got into work that day, 9 a.m. in the morning. This seems to be when all the bad things happen. Sat down, opened my paper, started reading it. 9:14 a.m., my phone rang. It was them. And I couldn't believe it. I just picked up the phone and I said, you're kidding. I recognized the number. I just said, you're kidding. And they said, yep, we're in. Not only they were in, they had compromised pretty much every Windows domain registry on the network. This is one of those things. If we don't have not only a solid perimeter, but a solid interior, the attackers are able to get in and pivot in very, very easy ways. So, remember those ports that I looked at for France when I went through? Part of that I went through and I looked at, there were SSH listening. So, at this particular one that I pulled out was a vulnerable version of SSH. For those of you who don't know, that's secure shell. It allows remote access in an encrypted fashion to a system. These are the vulnerabilities that we're applying to that particular SSH listener. How many SSH ports were listening in France when I checked yesterday? That is pretty wild. And don't worry, it's not just France, it's everywhere. This is the kind of thing where we have to make sure that we're doing proper due diligence and proper system hygiene, otherwise we're really opening ourselves up to some serious problems. We want to make sure that we are encrypting everything. There are so many times where I hear this government and that government wants unfettered access to your data. Tell them, show up with a warrant. Really, if you have access, if you have your data encrypted and you control the keys, they can't access it. Allowing them access under due process, fine. Allowing them unfettered access, not so much. So, for the, fix that. There we go. For the unified access security, formerly Zero Trust, these are the things you want to make sure that you are concentrating on. You want to make sure, especially, the groundbreaking piece of this is the asset inventory. I can't tell you how many organizations I have worked at over 25 years where this was not in place, or it was in a very broken fashion. So, the flaming sword of justice I refer to is the old way that security folks used to do things. That is going away. We are doing a better job as security practitioners to enable the business. We need the business to work with us in order to make sure this goes away. Because otherwise, we'll have to go back to this, and nobody needs the holy hand grenade of Antioch. Oh, good. There's Monty Python fans here. That being said, I would like to thank you very much for your attention today. If you have any questions, feel free to email me or conversely, join us on duo.com. Thank you.
Thank you, Dave. A big applause for Dave. Dave, well, a highly metaphoric and very nice picture on the way of your presentation. A lot of very nice design and metaphoric concepts for your presentation about security. So, do we have questions for Dave? Do we have questions in the room? You understood everything he said? Yes? Fantastic.
I don't bite.
Okay. So, Dave, what would be perhaps you talk about the security of perhaps the IoT? Is it for you one of the main challenges you had for the coming decade in security? You show example where you break into camera systems, into IoT server. Is it the main source of vulnerability you think today?
Well, to be fair, I didn't actually break into those systems. That was actually in a repository, but it is a trivial exercise to access a lot of these devices. And there was a botnet that came out 2 years ago. I was working at Akamai at the time, and we studied this botnet called Mirai. And the Mirai botnet was built with IoT devices. Now, there were 62 different sets of default credentials, again, static passwords, another hobgoblin strikes again, where all of these devices were then enlisted into this botnet and used to attack financial institutions, journalists, you name it. And so, yes, this is a real problem because, again, we're not paying attention to the security supply chain. We have these systems that are being delivered to consumers or industry that are using deprecated libraries in a lot of cases, as well as using static passwords. I mean, programmatically, it's very simple to set it up so that you are forced to change your password on the initial login. There's no reason for it to have a static, hard-coded password in these systems.
Yeah, okay. And we've seen that there are a lot of ports open and vulnerable to somebody who would not be well intended. And is it a question of only raising consciousness about security? Is it a question of education, or is it a question of more serious, raising its arm and investing in security?
I'm very much of the mind that is more of an education perspective because every country is susceptible to this, where they have all these ports open. It's not necessarily a bad thing, but there is a subset of those that are vulnerable. And we have to make sure that we're doing the due diligence, educating folks as to why this is a problem, and so that we can improve this in the future, because we don't need to be making the same mistakes of the past, as we've seen repeated with IoT devices.
Thank you very much, Dave. Thank you. And
Merci.
Last applause for Mr. Dave Lewis. And people can contact you after the conference if they want to. Thank you. Thank you, Dave. Mr. Ed Owen from the R2 company. Welcome, Mr. Ed Owen. Welcome to you.
Thank you. Good afternoon, everybody. And I'm fully aware that I'm the last person of the day and probably between you and the bar or the restaurant. So I will try and keep this as interesting as possible. What I wanted to talk to you today about was IT resilience. And it's been interesting listening to some of the other talks today, talking about security and how you secure your environment. And I guess my position is, what are you going to do if that security fails you? And it will fail you. So feel free to chuck questions at me, no problem with that. So digital transformation, everybody talks about digital transformation and what does that mean to you and your organization? And it means different things to different companies, but effectively it falls into 3 categories for us. So that's an evolution of your people and your technology within your organization, moving into new markets, new competitors, new business models, keeping up with trends, and obviously the ever-changing demands of your customers. And obviously, why is that transformation happening? Well, it's helping profitability, it's helping customer experience, and it's helping your speed to market, all things that are critical to your organization, regardless of the sector that you work in. And that digital transformation requires resilience in your IT organization. And what do we mean by that? And that's the ability to protect absorb and recover from whatever things happen in your environment. And those things kind of fall into two categories. So it's what we sort of historically talked about as disaster recovery. So that's, unplanned issues, errors, problems, often down to the users. We all know that the users are often the biggest cause of issues in our organizations. Infrastructure failures, and we've talked about today a lot of things around ransomware and security issues, and of course natural disasters, and those obviously things that we've seen a lot in 2017, 2018. But now it's moving into not just being able to react to those unplanned events, but also to use your IT and your IT resilience platform, as we would talk about, for planned events. So that's mergers, moving to the cloud, whatever that means for your organization, data center consolidation, and maintenance and upgrades. So it's no longer about reacting, but actually being reactive and being able to plan for whatever may come your way. And as I've said, those planned disruptions, mergers and acquisitions, moves, and moving to the cloud, and for some people, moving back out again if they realize that it isn't quite the right cloud that they've moved to. And then we've touched on some of this today, but the unplanned, excuse me, this microphone's dying. The unplanned disruptions, 250% increase in ransomware attacks in 2018 across the globe. 11.5 billion in cybersecurity that we know about, and it's probably far, far greater than that. And someone getting hacked every 14 seconds. And again, that's just the ones that we know about. So as I say, the ability to be able to protect your data, both during planned events, but also react to unplanned events. And we call that IT resilience. Now, IDC did a survey. You can Google this or feel free to drop me a note afterwards and we can send you a copy of it. IDC did a survey, and a staggering 50% of organizations admitted that they could not survive a natural disaster or some sort of disaster from an IT point of view. And 93% of organizations admitted that what they currently have in terms of IT resilience within their IT environment was short of what was required to be able to recover from either a planned or an unplanned event, which frankly I thought was pretty staggering. So only 7% of organizations are actually in a good place to be able to deal with either unplanned or planned IT issues. So there's an organization called Gartner, some of you might be aware of, and they've put together a magic quadrant for what IT resilience looks like, and you guys can read some of that for yourselves, but feel free to have a look on Gartner's website, and they can there's about 9 areas in the magic quadrant, and needless to say, Zerto falls into those, unsurprisingly. So, we talk about legacy solutions in terms of the IT resilience and backup space, and historically people have had array-based disaster recovery programs, backup applications that work on a 24-hour basis, and then applications in the cloud. We talk about DR as a service, backup as a service, and migrations. But actually the IT resilience is about bringing those things all together in one platform rather than having lots of legacy applications that often don't talk to each other. Unsurprisingly, I would stand here and tell you that Zerto can do that differently, and we have a platform that allows you to do that. In terms of IT resilience, it's about continuous availability. So it's not just about backing up your applications to a second site that may or may not work. The IT resilience platform, regardless of who the vendor is about being able to constantly keep a second site going, to constantly being able to move your workloads from one place to another, and move your applications into the cloud. And that might be AWS, it might be Azure, and it might be somebody else tomorrow. Can you do that today with your applications? Could you tomorrow stand up your applications somewhere else? And we've seen examples of this in the US with hurricanes, where customers are able to actually move their applications and their workloads on a Friday because they know there's going to be a hurricane over the weekend, and they can move those workloads, move those applications to another part of the country and go home safe in the knowledge that if that hurricane does hit, that they're not impacted by it. And again, everyone talks about multi-cloud, hybrid cloud. So that ability to be able to make use of cloud providers, hosting organizations, AWS and the big hyperscalers, IBM, or indeed any other organization as they may come on or change. And obviously these organizations are all changing, and many of them are getting bought by people. And we've seen, IBM just bought Red Hat. All these organizations are constantly changing. And it's that ability to be able to keep up with that change that's really, really important. DR as a service, again, a lot of cloud providers now using technologies like Zerto to be able to offer those services to those customers. So as a customer, there's no need for you now to have a second data center. You can point your applications to any number of cloud providers or organizations across the globe to allow them to do that for you. I'll skip through a couple of these. And I think that as a summary is a lot of organizations that we talk to on a daily basis who are using backup. And that's great, you've backed up your data, but how do you get it back up again? How do you make sure that if you need to get back to that data, it doesn't take you 2 days to recover? What organizations are you looking to help you to be able to recover from ransomware, etc.? Traditional backup, you take that snapshot at 12:30, and at 15:26 you get ransomware hacked. The very best thing that's going to happen there is that you've lost 4 hours of data, and it's cost you 4 hours of data, and that's your recovery point objective. Your recovery time objective is then how long does it now take you to get that data back up in a usable form. So it's a little bit like the analogy of you smash your car up, you're involved in an accident, the insurance company you hope will help you get back into a working car. You don't necessarily want the insurance company to give you a box of bits and expect you to put it back together again. And that is a lot of the time what happens with backup. And we talk to an organization, they've not tested it. And actually, when they have the problem, they realize actually their backup's no good. And their backup's no good because it's one application at 12:30, one at 2 o'clock, one at 3 o'clock. The web server doesn't talk to the database because it's from a different time, etc. So how do you get to a point where you can recover all of your applications or a subset of your applications from a single point in time so that when you recover it, it actually works? And that's what continuous data protection is. Think of it a little bit like in the UK we have Sky Plus, so it's like a live TV. So it's a constant data protection is a journal. So there's a 30-day journal, and there's every red line there is a point in time, and that's as close together as 5-second RPOs. So you get ransomware hacked at 17:26. We can roll back to 17:25 and 50 seconds, stand that up, check that it works. Assuming it does, then we're back up and running. We've only lost 5 seconds of data, which is quite a difference from a 24-hour backup where you've lost 24 hours worth of data. And we believe that's the future in terms of no longer working against a backup. And you still have the ability to restore files, virtual machines, because we work in the virtual environment with Hyper-V or VMware, restore apps and restore whole sites. And the evolution of that is what we call an elastic journal. So you would have a journal that gives you 5-second point in time objectives for the first couple of hours, and then obviously as time goes on, you don't need to be keeping 5 seconds, and you keep a day, a week, a month, a year, and you can keep that. And that gets to a point where you no longer actually need to have. I'm going backwards. You no longer need to have backups. You just have a journal, and then you can archive that off on a daily, weekly, monthly, yearly basis according to the requirements that you might have in your organization or within the geography or the technology landscape that you work in. So Zerto 7, just to that is what we do. There are other products are available. I'm obliged to tell you, but it's about that ability to mitigate risk, but also to be able to react proactively to whatever's happening in your organization, whether that be migrations or whether that might be moving to the cloud or whether it is reacting to some sort of ransomware attack or some sort of cybersecurity event that you need to recover from quickly. So, moving to this sort of environment means you don't have backup servers, you don't have agents, you don't have backup software or Windows, and there's no impact on your production. So your production environment carries on running. You can bring up your secondary site, you can test it, you can throw stones at it, you can do security testing, and then you can bring it back down again. And as we move forward in the environments, obviously today we talk about things like Hyper-V and VMware. And as we move forward, then the environments that we're looking at have containers, things like Docker and other applications like that. And then as cloud-borne applications come out, they will obviously need protecting. Vast majority of what we look at today is Hyper-V based or VMware, but that's obviously something that's also continually changing. So that was me. That's my email address on the slide. Very happy to take questions, and obviously as well, feel free to drop me an email if there's anything else that you wanted to ask. Thank you.
Thank you, Mr. Edowen. Large applause for Mr. Edowen. And this was very well presented and very interesting emerging concept of IT resilience, and how far. We had these backups, and now how the needs have evolved and changed, and how this is covering a more 360. So we have questions here. One moment.
Hello. I have a question. How challenging is it to bring an existing application, dependent, of course, from the site's organization, online? I mean, it's about migrating it to the cloud, and of course that's actually the core point of it. Even if we would handle small offices, doctors' offices, they are all enormous set of data, not to talk about a multinational operation. That might be actually the most challenging point, to migrate the stuff at once to the cloud so that you are able to run your journal over there. Because to my understanding, it's not running offline, so it's not running locally. Or
Yes, good question. So when we start or when we put Zerto in place, what we do is we do an initial what we call a delta sync, and that's obviously only as good as the link from site A to site B. We can do multi-site as well, so I can actually put you in a second data center, AWS, a cloud provider, simultaneoly. So actually it means you can keep your protection going whilst setting up a second feed. But what we can do also is if the data feeds to, say, your small sites aren't that great, what we can do is we can do and you can put it on tape, you can put it on disk, you can put that on your second site, spin that up, and then we will just do the changes. So that often takes a lot of time out of that process. So if you have a large data set in a small office, you can take a copy on whatever disk, tape, doesn't matter, put that on the second site, and then when we set the replication up, it will only replicate the changes, the block changes.
Thank you. Do we have more questions here? Head, I have a question. Is there a question there? Yes? No. Head, I have a question also to know a bit, what is your segment of the two customers? Is it large companies, medium-range companies, all sizes of companies, international companies?
All of the above. So we've got 6,000 customers, 350 cloud providers. I've got cloud providers running 7,000-8,000 virtual machines, down to customers that just run 20, 30 virtual machines. So we can accommodate the whole range.
All right. Okay. Thank you very much.
Thank you.
Thank you for your presentation. Large applause. Well, I would like to thank you, all of you, to have attended this conference session on cloud network is IoT. Now we have reached the conclusion moment. I would just like to emphasize that this is the first year at TRUSTECH that we are doing this conference on the cloud network and IoT. but I think it was very interesting exchanges. I appreciated very much. I hope we have more people next year and that you can also evangelize this conference session among your contacts. Thank you very much to all of you to have participated.